Hey, welcome back. In this video, we will learn how to do some basic web scraping with Go. Here we will use this framework called Collie that I like to use. But before we get started, I would like to add a disclaimer that while web scraping is not illegal, it is sort of a gray area legally, especially for bigger websites. So this video is for educational purposes only. With that being said, let's start by going over to the VS Code. Here I have initialized a basic Go project, and we also have the URL that we will try to scrape. So now I will install the package. That would be go get github.com go collie. And with that we have a go mod file. So let's clear. Let's declare a scrape function. It will take the URL, which is a string. And here we will use the scraping library by initializing a new collector. For now, we will leave the options empty. This should give us access to onRequest function. Let's add an inline function. This will give us access to request, which is a pointer to Collie request. Visiting request URL. We will also have an access to onHTML function. That would be c.onHTML. Here the first argument is the selector we want. We will come back to that shortly. And second parameter would be the callback with the HTML element. For now, I'll just print the element. And finally, we will use the visit function to send the request. Before we run this, let's talk about the selector. To understand this better, let's go to the page we are trying to scrape. Let's open the developer console. So I'll go to the left and click the select tool. And now we can select things more freely. So if I click here, it should take me to the element. And we can use this ID to select it. So our selector should be the ID we copied. As a side note, make sure using the correct CSS notation. And now let's call the scrape function and run our code. So we'll change this to scrape. And go down here and do go run main.go. If we scroll our output, we can see we got a lot of data. To find the correct data, we need to get more specific. So let's define and try to scrape our product. So we'll go here and do type product struct, and it should have a name and a price. For simplicity, we'll consider them as a string. Now let's go back to the browser. And now let's try to find the name. We can see we have a right column, left column, and a center column. So the price we want is on the right column. So we will open up the right column and try to look inside it. Or we can just use the select tool again and just click on the element. Perfect, we found the element ID. So I'm gonna copy this, go back to our code, and here we can select it. So we can do price, element, and get the child text with selector, right column, and the ID we copied. Similarly, let's try for name. I will use the select tool again, go to the name, and we can see it's in the center column, product title. So I'm gonna copy this, go back, and use it similarly. So name, element, child text, center column with ID, product title. And now we should be able to make a product. So product, name, price. And now let's run this. So go run main.go. Seems like our selectors worked. So I'm gonna clear it. And now let's do a fun exercise by scraping multiple URLs and saving the results in a CSV. For that, I will change this to URLs, and this would be a slice of string. Now I will add some more URLs. We will also need to update our logic by using a for loop. So this would be for URL range over URLs. And I will move the scrape function inside the loop. And now let's go to our scrape function and return a product. Going back to the main function, let's also store a result in a slice of products. And now I will just append the results. So product, products, append, product. Now that we have a product, let's focus on writing it to a CSV. So first, let's create a file using OS, create. I will name it as data.csv, and this should give us back a file or an error. Let's handle the error. And here we'll use log.fatal. I will also use defer to make sure our file gets closed. And finally, let's use the encoding package and create our CSV writer. So writer csv.newWriter, and we can pass our file here. And finally, we can simply loop over the products and write them to CSV. Range of products, writer.write. It would be a slice of string. We can do product name and product price. Before we run this, I will add a line before our loop to add a header. So this is our name and price. We will also need to flush our writer. We can do that by using defer writer.flush. Before we run this, let's measure how much time it takes. So we'll go to the main function. Here we can use the time package and go to the very end and get the time lapsed by simply doing time.since t and format it to seconds. Now we can just print it. I will use printf and do time. And now let's run this to see how much time it takes. So I will do go run main.go. On the left, we can see it created a CSV file. So let's open it. And here we can see we have our name and price. But if you noticed, it took over 25 seconds to scrape only small amount of data. So now let's see how we can optimize this by introducing some concurrency using Goroutines. I'll start by going over to our main function and declaring a channel. Let's name it as ch make channel of type product. And we will also need a wait group. We can use a sync package to import the same. Let's add to our wait group. Here I'll just add the length of URL slice. Going over to our loop, we can no longer wait for the product. Instead, we'll use our channel. So I'll pass channel here. And to make this function concurrent, we will prefix this function by go keyword. Now let's go to our scrape function. Here we will have the channel of type product, and I will also restrict the channel. Here, instead of returning, we will send the product to our channel. We can remove this as well. Now let's focus on the receiving side of things. For that, I will create another for loop where we will receive the data. So for range over URLs. Here let's create a concurrent anonymous function. And first of all, we need to define our weight group. We don't need to add any weight group as we did that earlier. So now we can simply receive our data from the channel. And append it to our slice. So we can use this line. We will also need to wait for this to complete. So wait group.wait. And once we have received all the data, we can close our channel. Here we can use the close function. And now let's try it out. So we'll clear this, go run main.go. Check our CSV file. We have our data as expected. But now if we notice the time, it only took 2 seconds. So that's the power of concurrency. And I wanted to show you how we can improve our scraping. While this code is not production ready, we can certainly use mutexes, buffer channel and much more to improve this, but I will leave that up to you. Lastly, I will commit everything to this repo. So this is it for this video. Thanks for watching. I'll see you next time.